Okay, so you had questions on page 527 first. Question number 9. A step-down transformer has 7,500 turns on the primary. So that's NP is equal to 7,500. And 125 turns on its secondary, NS, 125. And we don't tend to write turns, it's just a number, right? The voltage across the primary, VP, is 7,200 volts. And what is the voltage across the secondary? So VS over VP equals NS over NP. So VS equals NSVP over NP. 125 times 7,200 divided by 7,500, and the 7,200 of course is volts, and you should end up with 120 volts. That's part A. Part B asks, what if the current in the secondary is 36 amps, so IS is 36 amps, what is the current in the primary? So IP over IS, and remember these ones are backwards, so this will be VS over VP, or actually it probably should use the N's because you know they're right, so NS over NP. Bring the IS up, so IP is equal to NSIS over NP. NS was 125, IS was 36 amps, and NP was 7,500. 125 and 7,500 reduces, right, to 60. So that's like 36 over 60. So 0.6 is equal to 0.6 of an amp. Okay, it started the question out by saying step down, and it is a step down. You start with 7,200 volts and you go down to 120 volts. So it's definitely a step down. The voltage is less, and when the voltage is less, the current becomes more. So the initial current was only 0.6, the final current 36 amps. Number 10, the secondary of a step-down transformer has 500 turns, so NS is 500 turns. The primary has 15,000, so NP 15,000 turns. The EMF of the primary, so V primary, is equal to 3,600 volts. What is the EMF of the secondary? So VS over VP should be equal to NS over NP. Bring the VP up. So VS equals 500 times 3,600 volts over 15,000. So these three zeros cancel out with 3 of those. 5 goes in there 3 times, so you have 360 over 3. So I think it's 120 again. And the current in the primary is 3 amps, so in part B, I primary is 3 amps. What is the current in the secondary? So I secondary over I primary, and again I'd use the N's because we know they're right. N primary over N secondary, because remember the currents are opposite. If the S is on the top on one side, the P is on the top of the other. So bring your I primary up. So IS equals 15,000 over 500, and your primary was 3 amps. So that's 30 times 3. I think your I secondary ends up being 90 amps. It should be bigger. The voltage should be smaller because it told us it was a step-down transformer. All right, turn the page. Number 11 says an ideal step-up transformer's primary circuit has 500 turns, so NP 500. Its secondary circuit has 15,000, so NS, so they've just switched them up here on us from the last one. The primary is connected to an AC generator having an EMF of 120 volts. So EMF, which is really V, and it said primary, right? Yeah, is 120 volts. Calculate the EMF of the secondary. So you're looking for Vs, so Vs over Vp is equal to Ns over Np. Bring your Vp up. Vs is equal to 15,000 over 500 times 120 should be about 3,600. Right, 2 zeros cancel. You're 30, yeah, 3,600 volts. Is there a part B? Of course there is. Find the current in the primary if the current in the secondary is 3 amps. So I secondary is 3 amps. So I primary over I secondary equals N secondary over N primary. Bring this up here. I primary is equal to 15,000 over 500 times, what did it tell me? Secondary was 3 amps. So 30 times 3, I think it's 90 again, is equal to 90 amps. And there's a third one. What power is drawn by the primary? What power is drawn by the secondary? So in part C, power is equal to IV. So power in the primary is equal to I in the primary, which was 90 amps, times V in the primary, 120 volts. Power in the primary, what is that? 108? 108 and 2 zeros, I believe. That's power in the primary. Power in the secondary is equal to I in the secondary, V in the secondary. I in the secondary was 3 amps times 3600 volts. So power in the secondary is 10800 watts. And look at that, they're the same. It is indeed an ideal transformer. Number 12, ooh, it has an arrow. It says a step-up transformer has 300 turns on its primary. So P primary, 300. And 90,000 turns on its secondary. P secondary, 90,000. The EMF of the generator, which is the primary is attached to, so V primary, 60 volts. What is the EMF of the secondary? So V secondary over V primary equals N secondary over N primary, bring the V primary up. N secondary, 90,000 over 300 times 60. 3 goes in there, 3, 2 zeros disappear, so 300 times 60 should be 18 and 3 zeros. So 18000 volts. And the B, the current flowing in the secondary is 0.5 amps. What is the current in the primary? I don't know why this has a asterisk beside it, that it's any different than the others. So the current in the secondary is 0.5 of an amp. So the current in the primary over the current in the secondary is equal to the in secondary in primary. Bring your current in the secondary up. So 90,000 over 300 times 0.5. So again, that should be 300. Half of 300 should be 150. I secondary equals 150 amps. It's at a step up this time, and it is, because it went from 60 up to 18,000 in the voltage. And then, of course, if the voltage goes up, the current has to go down. It was 150 amps, and now it's down to 50 amps. Okay, so those are the questions on page 527. I'll do a second video of the ones over on 533.